Second topic for the day. Correlations measure relationships. Many times we're interested in the relationships between variables, but the other thing that many times we're interested in doing is seeing if one thing might predict something else. Does anybody know what statistic we use if we want to know if A might predict B?
I'd like to guess maybe a regression, as that's the next thing.
Bingo. Regression. I always ask terribly simple questions, especially with statistics, to kind of validate people's, yes. Regression, when you do regression, the business of regression is the business of trying to predict things. Correlations measure relationships. They do not measure predictions. They are very related, though, correlations and regression. So there are different types of correlations and regressions you can do. In simple linear regression, you use one variable to predict a second variable. So simple linear regression is where you use one variable to predict a second variable. And both variables need to be continuous here. If we go back to page 1 of our data set, you got BMI and you got snoring. What would you want to do there? What would you want to use to predict what?
Lowering BMI, lower snoring.
So can BMI be used? BMI would be considered the predictor variable to see if BMI might predict snoring. That would be a simple linear regression situation. I don't have that particular data set up there, but you could do that, and I'll show you some other situations as well. And if you look at the first page, simple linear regression, you put a variable in. Now sometimes it says enter the independent variable. I don't like to call them independent variables. What term did I use? I didn't say independent. Predictors. Because BMI is not manipulated. SPSS uses the word independent. I like to use the word predictor, but if you have a faculty mentor who says call this an independent and the statistician said otherwise and you're told call it an independent, then you call it an independent because you do what you're supposed to do. And the statistician just knows that that's not quite the right thing to do. Life goes on. I've had that happen. So you put that variable in. The method is just called the enter method. And what I've shown you here on the first page is that variable was put in, the BMI, to try to predict snoring. Now, if the correlation is high, do you think BMI will be useful in predicting snoring here?
Mm-hmm. Yes.
Yes, it will be. So we have a few screens below that. Notice that the dependent variable, and I would call it a dependent variable, is snoring frequency. I have predictors and I have DVs. The DV here is snoring frequency, and I'm fine with that. So there are a few screens below that. The first one says model summary. There's one thing to circle with model summary. The thing to circle is adjusted R squared. And you may want to take a note or two on adjusted R squared. Let me give you the real world statement about that adjusted R squared. And you may want to just write this down verbatim. The idea here is that if you know BMI, you can account for 78% of the variance in snoring. If you know BMI, you can account for 78.4% of the variance in snoring. Is that pretty good?
Yep. Yes.
What would be the top amount that you could account for?
100%.
100%. So one variable that accounts for 78% is pretty good. So the only useful thing in that model summary, and notice they have some big R's there. You don't need to know about that here. But the adjusted R squared basically says that if you know the predictor variable, you can account for this much variance in the DV. And if you make a pie chart, if you know BMI, you can account for over 3/4 of the variance in snoring. It doesn't mean you'll predict it correctly. 78% of the time, but you can account for 78% of the variance. So that's the model summary screen.
Can I ask?
Please.
I don't understand how we can be confident in knowing that it's that much of the variance if we haven't considered any other variables.
So it's just this situation. It is only this situation with snoring and BMI
Okay.
that we're looking at. And in this very simple situation for a teaching example, which you would never have in the real world actually, in this situation, BMI in a teaching example can account for 78% of the variance in snoring according to these 5 people. I made it
What
just
I've seen with this most of the time
simple.
is that they dump in a whole laundry list
Oh,
of
yeah.
things, and they run these, and then they try to figure out which ones of them are predictive.
So we'll get to that
Yeah.
next, but this is step 1.
Okay.
So this is simple linear regression.
Know your variance of one variable simply by knowing that one variable. You
So-
don't have to know everything in the pot.
In this situation, that's the next situation we'll get to. And then the bottom screen, even though you don't quite, it's weird that you see an ANOVA here, you can actually do an ANOVA on this situation. It's not critically important you understand how that's done, but the important thing is the sig value at the end. What's the sig value there?
0.029.
0.029. So what that tells you, the real world statement, if you circle that 0.029, is that the 78.4 is
Significant.
statistically significant. And the way you write that out, if it's an F, you write out the letter F, and then in parentheses,
Why would we do an F?
it can do an ANOVA.
Oh, okay.
I can say a little bit about it.
Sorry, I didn't switch
No, it's
gears
okay.
from regression to
No,
ANOVA.
it's a relevant question. So when you do a scatter plot, what basically happens is a best fitting line gets drawn
Uh-huh.
through the data points. And the idea is if the points are really close to the line, then the numerator, what's called the regression here, that's going to be a really large number.
Mhm.
And the difference between that best fitting line and the data points, that's going to be the error.
Mhm.
And so you can do an ANOVA. SPSS will do an ANOVA on that. And in this situation, what you can see is that for the regression with this if we made a scatter plot out, it'd be very easy to draw a best fitting line where all the points almost map right onto. It's actually the 80 that throws it off just a little bit. That the regression is accounting for a bunch. So you could do a sum of squares. Notice the mean square for the regression is over 2,600. The residual, the difference between the line and where the points actually were, is very small. And so you are statistically significant. So the way you write that out is F, and in the parentheses, 1, 3. You see that there for the degrees of freedom for numerator and denominator? The 1 and the 3 equals 15.511, P equals 0.029. And the real world statement is the 78% is statistically significant. Let me show you in my piss poor
So
penmanship.
do you have to always do an ANOVA when you do
So-
a regression?
Is that a parentheses 1, 3?
Yes, sorry.
Are they buddy?
It's usually done.
Okay.
It's usually done.
It's a buddy thing.
Yes. Oh, the one other thing I needed to say, that adjusted R squared is given a name. It's called the coefficient of determination. The coefficient of determination says if I know this, I can account for that much of that.
That's what I'm going to go as for Halloween next year. Say the coefficient of determination.
There you go. You can sound like
That
a
will
big
certainly
shot.
intimidate some people.
So this is simple linear regression. What we've done here is, why is it simple linear? It hasn't been that
funny.
simple. one,
Variable.
one predictor and one DV. And so with one predictor, one DV, we entered it in, the adjusted R-squared, we accounted for 78%. If we know BMI, we can account for 78% of snoring. Would that be useful if you're a clinician?
Not if I can't impact the BMI or the snoring.
Yeah, but if you collected
Only
this
if I can
data,
change this BMI.
if you collected this data and you had somebody with a serious sleep apnea problem,
Yeah.
what would you probably tell them to try to do?
Lose weight.
Lose
Try to
weight.
lose weight. Does the data support that contention?
Yes.
Yes. So then you could do your intervention study, but that's
And then
not
the
this gig.
poor person would be in the 22% that continues to snore. even after
Continues
they
to
lose weight.
snore. So the F is significant here, and that is simple linear regression.
That person lives in my house.